Welcome back. This is homework 7, calculating dew temperature and the bubble temperature using Google Cloud Jupyter Notebook. This is part 2, I think, of the part 3 series in the project that we were assigned. My other partners are Matt Fleming and Brett Evil, and I'm Cody Limp, showing you how to do the coding part. So let's get started. So the first part up here, we have get clone death, HTTPS, the web link. This basically grabs data from the web link my professor created, where it has all the important chemicals that we need, basically, and the elements we need to calculate the problems in this assignment. So right here, like all this, like from .mat, import .mat, that's the .mat we'll be using to make the plot. Import JAX, that's a number system. Import JAX as numpty as JMP, that's just shorthand for JAX numpty. And then from JAX configure, import config, it's also just another type of number system. And then from plotty.subplots, import make subplots, that's making subplots for the range and temperature and pressure we're doing. And then arrays, import VCS comp range array. That's what we'll also be using. Import tools as .che as che. That's also what we'll be using. It's just shorthand. CH tools is what basically, excuse me, what my professor made that we use to help calculate methanol isopropanol. Now, P is equal to ch.props, methanol isopropanol is what we'll be using basically to calculate the temperature and the pressure for the dew and bubble model in the below. And define bubble T, return jmp.sum c.x ct times pvap c dot. That's basically the formula for what we'll be using to calculate the lines below. Now c equal to dot map, that's basically the map that we'll be using to plot. And c.x equal jmp.array, that is the mole fraction basically for the x-axis. Ct is the range for the y-axis. Cp is the pressure value going in. Ct.range is also just another array of ranges. And then vc.vc comma bubble t is like the array used to calculate this. We'll point out a number, and you'll see that right here where it says 346, and that's the temperature range. It's one of the temperature values. All right, and then same here again, define dew temp. This is defining the dew temp now. And then c.map is basically the same thing, but just for the dew temperature. The one up here was the bubble temperature. This one's the dew temperature. And it prints out that value. All right, c equal dot map dot times ct equal range. That's the range for the temperature. P 1100. 101,325. That is the pressure value going on. And mole fraction jp dot line space. That just helps make the lines. And define solve bubble T, and this is basically using the array to solve the bubble down here. Cp equal pressure, VC, turn VC, yep. And then the bubble array makes the mole fractions for the bubble T array. And then it's the same thing right here. It's making the mole fractions for the dew temperature. And then down here we have the fig make subplots, fig as scatter equal x equal mole fracs, y equal bubble T array, name liquid, mole mode lines. And then as you can see basically right through here, this is how the graph is made from the fig.update or fig.add scatter. And all these plots basically just help make the plot used for bubble and dew temperature. All right, well, that's basically it for today. It's not too hard, and the temperature, the system used is actually really good. It's really nice. If you want to change some things up, you can go back and change the pressure to like, just add a bunch of 5s, all right? And then runtime, run all. We'll see what happens. It takes a second to load. A lot of code running at once, and my computer's kind of slow. Hopefully it runs. Come on, run. I don't know why this is taking so long to run. Maybe the pressure value is too high. And it's having a hard time solving all that right now. That's most definitely it. But how about we just change it down to set a really big number, really small number. Okay. Okay, so that really messed things up, but you can see how that changes the graph when it's a really small number. Yeah, so this is actually really bad because it looks nothing like what we were supposed to find, but you get the point of how this code works now. All right, well, thank you for coming to my YouTube video today, and I hope you enjoyed this short video about coding the dew temperature and bubble temperature using Google Colaboratory. Thank you.